Hello student, this is Latif sir. Today I'll discuss about discovery of nucleus, Rutherford atomic model and discovery of Newton. In the previous video I have already discussed about the discovery of protons and discovery of electrons. Today I am going to discuss about the first discovery of nucleus. In 1911, scientist Rutherford first discovered nucleus by the experiment known as alpha particle scattering experiment. Alpha particle scattering experiment on gold foil. Okay, on very thin gold foil. Huh. By the experiment of alpha particle experiment on a alpha particle scattering experiment on a very thin gold foil, Rutherford first discovered nucleus. Here one point you have to remember, that what is alpha particle? Alpha particle is a doubly charged helium ion, that is He2 plus ion. We know that helium atom, which contains two protons, two neutrons and two electrons. But alpha particle is a doubly charged helium ion, that is He2 plus, which contains two protons and two neutrons only. And alpha particles is formed by removing two electrons from helium atom. In the alpha particle scattering experiment on a very thin gold foil, Rutherford used alpha particle and he bombarded the gold foil by alpha particles. He selected a gold foil because he wanted as thin layer as possible. He wanted as thin layer as possible, and gold is the most malleable metals. That's why uh, it is possible to make a very thin layer of gold foil. Okay, that's why he selected gold foil for his experiment. And the name of the experiment, I have told that alpha particle scattering experiment. In this experiment, Rutherford observed that when he bombarded the gold foil with alpha particles, most of the alpha particles went straight through the foil. Most of the alpha particles went straight through the foil. Some of the alpha particles were slightly deflected from their straight path. Some of the alpha particles were slightly deflected from their straight path, and very few, nearly 1 in 10,000 alpha particles were either deflected by very large angle or completely bounced back, that is uh, in a 180 degrees angle. Okay, these are the observation of alpha particle experiment on gold foil, alpha particle scattering experiment on gold foil. In figure 7.5, you can see here, this is actually the scheme of alpha particle experiment. When alpha particle is passing through the very thin gold foil, some of the alpha particles went straight through the foil, some alpha particles were slightly deflected from the straight path, and very few, nearly 1 in 10,000 alpha particles were either deflected by 180 degree. Okay, you can see in the figure 7.5 deflected alpha particles, how the alpha particles are deflected. Okay, and observation I have told. From this experiment, Rutherford conclude that uh, maximum space in an atom is vacant. Okay, and using this conclusion, Rutherford give atomic model. Okay, so Rutherford generalized this result of alpha particle scattering experiment and suggested a model of atom that is known as Rutherford atomic model. And what is Rutherford atomic model? According to this model, according to Rutherford atomic model, atom consists of very large empty space, which is extra nuclear space. I have told that uh, using the conclusion of alpha particle scattering experiment of Rutherford, that is maximum space in an atom is vacant. Okay, or empty space, maximum space are empty. So according to Rutherford atomic model, the atoms contain a large number of empty space. This is why most of the alpha particles pass through the metal foil, through the gold foil, thin gold foil, without any deviation from their path. And second point of Rutherford atomic model is there is a positively charged mass at the center of atom. There is a positively charged mass at the center of the atom, which is known as nucleus. And from this alpha particle experiment, Rutherford discovered nucleus. Okay, so what is nucleus? In an atom there is a positively charged mass at the center of the atom, which is known as nucleus. In nucleus, the entire mass of the atom is concentrated. Therefore the nucleus is the densest part of the atom. The electrically positive nature of nucleus is supported by the fact that positively charged alpha particle approaching the nucleus and get deflected. Generally, from this point that alpha particles deflected from the nucleus, uh, and you know that alpha particles are positively charged particles and they are deflected from the nucleus, and you also know that same charge of particles of same charge are repels to each other. That's why when alpha particle approaching the nucleus, they get deflected. From this point, this proves that the nucleus contain protons. So in nucleus protons are present. So and you know that protons are positively charged particles, so charge of nucleus is also positive. Third point of Rutherford atomic model, the size of nucleus is very small. The size of nucleus is very small compared to the size of atom. And fourth point, the electrons revolve around the nucleus at large distance from it. That is, electrons revolve around the nucleus at large distance from it in the circular orbit found in the empty space of the atoms. So electrons revolve in circular orbit outside of nucleus. Okay, and next point, an atom is a whole. An atom as a whole is electrically neutral. That is, an atom is always neutral. An atom as a whole is electrically neutral. This is because the total number of positive charge of the nucleus, that is total number of protons in the nucleus, which is balanced by the total number of negative charge, that is total number of electrons uh, in the outermost orbitals, electrons present in the orbitals around the nucleus. You know that I have told that electrons are revolving around the around in different orbits around the nucleus. And in an atom, total number of negative charge and total number of positive charge always equal. That's why atom as a whole is electrically neutral. And electrons revolve around the nucleus in closed circular path, and these paths are called orbits. I have told. Okay, so this is the Rutherford atomic model. The figure 7.6 you can see at the center of atom, which is known as nucleus, and nucleus contains positively charged particles, subatomic particles, which is known as protons, and electrons are revolving around the nucleus in different circular path, which are called orbits or shell. Okay, and there is a strong electrostatic force of attraction between the negatively charged electrons and positively charged nucleus. Okay, the force of attraction between the negatively charged electron and positively charged nucleus is counterbalanced by the centrifugal force acquired by the revolving electrons. So these points are the atomic models, main points of these are the main points of Rutherford atomic model. Okay, and now drawback of Rutherford atomic model. One point you have to remember that Rutherford's atomic models or model of atomic structure is similar to the structure of solar system. That is, there is a similarity between the Rutherford atomic model and solar system. Just as in solar system, the sun is at the center having the maximum mass and the planets revolve around it. Similarly, an atom, similarly, an atom in an atom, the nucleus contains the main mass, and the electrons revolve around it in orbits or in shell. Okay, so the Rutherford atomic model is at the center of atom, which is called nucleus, in which protons are present, that is total mass of orbital present at the nucleus, and electrons are revolving in orbits in circular path around the nucleus. This is the Rutherford atomic model. Okay, now there is some drawback of Rutherford atomic model. So let's see what is the drawback of Rutherford atomic model. According to the classical law of mechanics and electrodynamics, if an electrically charged particle is in motion, then it radiates energy. According to classical law of mechanics and thermodynamics, if an electrically charged particle is in motion, then it radiates energy. And according to Rutherford atomic model, I have told that electrons are revolving around the nucleus in circular path or in orbits. That's why an electron, when moving around the nucleus continuously, should radiate energy. That is, the electron loses energy. As a result, the electron should be gradually pulled towards the nucleus because it radiates energy continuously. And this is happening according to the classical law of mechanics and thermodynamics. That is, when a charged particle moving in a circular path, it will radiates energy. That is, it will lose energy. So electron revolving around the nucleus. That's why similarly electron will radiates energy or loses energy. As a result, it should be gradually pulled towards the nucleus and end up colliding with the nucleus. So after some time, within very small time, that is within 10 to the minus 8 second, the electrons will collide with the nucleus. That is the elect the nucleus will collapse within very few seconds, 10 to the minus 8 second. That's why this should result in the total collapse of the atom. Okay, nucleus will collapse means atoms will collapse. That is, there is uh, the atom become very unstable. Okay, so if it was so, the atom should be highly unstable, and hence matter would not exist in the form that we know. However, we know that an atom is structurally stable. That is, this phenomena is not happening in atom, but according to classical law of mechanics and thermodynamics, it should happen. Because electron is charged particle, when it revolving around the nucleus, it continuously lose energy, and finally radius of circular path gradually decreases, and one times at a time electrons will collide with the nucleus, and finally and the nucleus will break down. Okay, that is, the nucleus will collapse, that is, the atom will collapse, but actually this is not happening. Okay, but why this is not happening, uh, Rutherford not explain. Okay, that is, the Rutherford atomic model could not explain this stability. Okay, so using Rutherford atomic model, you can't explain the stability of atom. This is the drawback of Rutherford atomic model. Now, Bohr's atomic model. In 1913, Niels Bohr, a Danish physicist, explained the cause of stability of the atom in different manner. And the main postulates of Bohr's atomic model are: first, the electrons revolving around the nucleus are confirmed confined to certain fixed orbit, which are called shell or energy level. The main postulates of Bohr atomic models are: the electrons revolving around the nucleus are confined to certain fixed orbit, which are called shell or energy level, each of which is associated with a fixed amount of energy. Okay, each energy level or energy cell associated with a fixed amount of energy. Who told? Bohr, Niels Bohr. Okay, and second postulate: while electron revolving around the nucleus in an orbit, an electron does not lose or gain energy, but in according to classical classical law and mechanics, classical law of mechanics and electrodynamics, electrons should radiate energy, but it is not actually happening. Huh. So both scientist Niels Bohr told that while electron revolving around the nucleus in an orbit, electron does not lose or gain energy. This is actual phenomena. Electron will not uh, lose or gain energy when revolving around the nucleus. Okay, and the third postulate: an electron revolving in a particular orbit, on gaining a certain amount of energy, it jumps to the next orbit, and vice versa. That is, if an electron gets gain energy, it will jump to next energy level or orbit. And similarly, if an electron really lose the energy, it jumps towards the lower energy level. Okay. So since each orbit is associated with fixed amount of energy, Bohr called it an energy level. Okay, so each orbit or each cell is called energy level because each orbit has a fixed amount of energy. And Bohr, scientist Niels Bohr, uh, marked this energy level by using the letter English letter K, L, M, N. Okay, so for convenience, these energy levels are labeled as K, L, M, N, capital K, capital N, L, capital M, capital N, okay, etc. And the orbit closest to the nucleus is the K cell, and then L cell, then M cell, then N cell, and like this. Okay, you can see here the energy level around the nucleus of an atom, which is a Bohr's model. Figure 7.8 is the Bohr's model. Okay, so I have told today I have told about discovery of nucleus, Rutherford alpha particle scattering experiment. Okay, Rutherford atomic model, drawback of Rutherford atomic model. You have to remember the drawback of Rutherford atomic model. Read carefully, very. And next, Bohr's atomic model, and in Bohr's atomic model, how electrons are revolving in different cell, different energy level. I have told, and okay, and one important point in Bohr's atomic model, that when electron revolving in a particular orbit or particular energy level, it will not lose or gain energy. It will not lose energy when it is revolving in a particular orbit. That's why the electron never collapse with never collide with the nucleus. That is the nucleus is actually stable. Okay, but according to law of classical thermodynamics, classical law of dynamics, mechanics, and electrodynamics, when charged particles revolving around a circular path, it will release energy, and its radius of circular path become gradually decreases, and finally at a time the charged particle will collides with the nucleus. That is, electron will collide with the nucleus and nucleus become unstable. But the nucleus is actually stable. But why this is not happening? Why the nucleus? Uh, why the nucleus uh, uh, become stable? The Rutherford could not explain. This was the drawback of Rutherford atomic model. Okay, but the Rutherford atomic model was correct. Okay, but Rutherford could not explain the stability of atom. This is the Rutherford drawback of Rutherford atomic model. Okay, and then Bohr gives a atomic model, Niels Bohr. And now discovery of neutrons. In 1932, Chadwick, James Chadwick discovered neutrons by bombarding light nuclei like beryllium with alpha particles. So Chadwick discovered neutron by bombarding beryllium with alpha particle, and these particles are found to be neutral, so they are so named as neutrons. A neutron is a subatomic particle like proton and electron. and there is no charge and mass, no charge of neutron. That is, neutron is neutral particle. Okay, and mass of neutron is almost equal to the mass of proton. You have to remember, mass of neutron and is almost equal to mass of proton, and neutron is denoted by the symbol small n 1, small n 0. Okay, where the superscript 1 represent the mass and subscript 0 represent the electrical charge of neutron. Now, properties of neutron. Neutron is electrically neutral particle, and its mass equal to almost equal to the mass of proton, which is equal to nearly about 1.676 into 10 to the minus 24 gram or 1 AMU. Okay, after the discovery of proton, neutrons and electrons, that is these subatomic particles, it was found that all atoms have similar following basic structure. Electrons are negatively charged particles that are found outside the nucleus in different orbits. Protons are positively charged particles that are found in the nucleus of an atom, and neutrons are electrically neutral particles that are also found in the nucleus. Neutrons are slightly heavier than protons. You have to remember, among three subatomic particles, that is proton, neutron and electrons, neutrons are slightly heavier than protons, and mass of electrons is very negligible. Okay, now here comparison of Dalton atomic theory and modern atomic theory. So let's see. In Dalton atomic theory, atoms are indivisible particles, but in modern atomic theory, atoms are divisible into different subatomic particles like protons, electrons, neutrons. Okay, second point, atoms can neither be created nor destroyed. According to Dalton's atomic theory, atoms can neither be created nor destroyed, but according to modern atomic theory, atoms can be created and destroyed by nuclear fission or fusion reaction. That is, atom can be created and destroyed. Next point, according to Dalton atomic theory, the atoms of an element are alike, that is similar in all respect. According to Dalton's atomic theory, atoms of an element are alike in all respect, but they differ from the atoms of the other elements. But in modern atomic theory, atoms of an element may not be alike in all respect. May not be alike in all respect, as in as is seen in case of isotopes. Isotopes, although isotopes are elements of same atoms of same elements, but they differ in physical property to some extent. And the last point, according to Dalton atomic theory, atoms follow the law of chemical combination to form compounds, but according to modern atomic theory, the formation of organic compound in the formation of organic compounds, the law of chemical combination are not always followed. Okay, thank you.